Oh my God, Logan, we made it. We've gotten to the last three questions. Now, you'll notice that these three questions are a little bit different than the last four we did, primarily because this is not talking about angles and arcs. Some of you are like, well, how can you tell it's not talking about angles and arcs? I don't see anything that has anything about degrees. There's no degrees on any of these problems. What this means is this is talking about all the segments. So for the first problem, question number 20, we're going to find out what x is. So these last three problems, we're focusing heavily on the segments. So this one, when they intersect inside the circle, what we do is we take the pieces of the segments and we're going to multiply them together, and they should equal the other chord's pieces. So we're going to grab all those pieces and we're just going to multiply them by each other, and they should equal the other products of those other chords. So we're going to take the green one, which is x plus 5, and we're going to multiply it by the blue one, the 28. And that should equal taking the red one, 2x, and multiplying that by the black one, 21. So the theorem states that if two chords intersect in a circle, then the product of their pieces must be equal to each other. So we just do a little bit of math on this guy. So we're going to use distributive property over here. That's 28x plus 140 is equal, and then 2x times 21 is 42x. We're going to go ahead and get the x's all onto one side, so we're going to get rid of the 28x over here, and this gives us 140 is equal to 14x. Well, it's kind of nice. Dividing both sides of the equation by the 14, we find out that x is equal to 10. And we have our first segments of circles solution. All right, let's move on to question number 21. 21 says find x, and this time we have two secants that are intersecting. So with these ones, it's really important for us to remember we need the entire secant and the outside. So first thing we're going to do is we're going to take a look at the top one, and I'm going to say that the entire secant is the part on the outside plus the chord that's on the inside. So the entire thing is going to be 4 plus the 2x. I'm going to do the same thing on the other chord, the other secant. I'm going to take the entire thing and say the outside part plus the inside part, the chord, has to equal the entire segment. I'm going to go ahead and simplify this blue guy right here. I'm just going to say 3x plus 4, tidy it up, add the non-x's together. The way that this formula is going to work is we're going to multiply the entire segment by the exterior. And we're going to do the same thing on the other one. We're going to multiply the entire segment by the exterior. So we're going to multiply those pieces together, and we're going to solve that equation. We'll start with the red one that's highlighted in green. 4, the outside, times the whole thing, 4 plus 2x, is going to equal, let's take a look at the pink and blue one, the whole thing, the outside, which is 3, times the whole thing, 3x plus 4. And we're going to go ahead and just kind of solve it by using distributive property. 16 plus the 8x, for those of you that need to see it, just multiplied right there. And then 3 times 3x, which is 9x. 3 times 4, which is 12. Those have to be equal. I'm going to go ahead and get all the x's onto the right side. So I'm going to take away the 8x. And I'm going to get all the non-x's to the left side, taking away the 12. This gives us 4 on the left, just 1x on the right, and there's our answer. X is equal to 4. Moving on to the last question. Hopefully, it's all been making sense. And once again, if it's not, come and talk to me Friday morning. Maybe we can hammer out some of these questions. So this one here, we have a secant and we have a tangent. So first thing we're going to do is anytime we're dealing with the secants, we always want to figure out, well, how long is the entire secant? That's 24 plus the x. The outside plus the inside, the chord. So the way that this one works is we're going to multiply the 24, the outside, by the whole thing, the 24 plus x. And then we're going to multiply the 36 by the 36. So the 36 is going to end up getting squared on this one. So let's do the math. 24 times 24 plus x is equal to the 36 raised to the power of 2. So now we're going to distribute 24 times 24 and x times x. Ooh, I am not prepared. I think it's like 576. but don't quote me on it. So what we'll do is let's split view this guy. Let's get some Desmos going on, and we'll type it in. So we'll go 24 squared. 24 to the power of 2. Hey, there we go, 576. I generally don't know the ones larger than 17. And then we get 24x is equal, and then we'll do 36 squared. Ooh, that's not what we want. Let's ignore that guy. 36 to the power of 2 is 1,296. All right, that's all we probably need for Desmos right there. Let's go ahead and solve this guy. Subtracting the 576 from both sides. I guess having a calculator would be nice for these larger numbers, but I think we can brute force this guy here. 24x is equal to 720. We're going to go ahead and divide both sides of the equation by 24, and we get x equals. I don't know off the top of my head, so I know that 12 times 60 is 720. 12 times 6 is 72. And I know that 24 is 12 times 2. So this is me canceling without a calculator. The 12s cancel out, and then I get 60 divided by 2. In other words, half of 60 is 30, and we now solve that x is 30. All right, you did it. You made it to the end. Now all we got to do is make sure that we get a good night's rest, do a little bit more studying. Don't forget to make your cheat sheet, half a page, only one side. And I will see you guys on Friday. Oh, we're so close to the end. I'll talk to you guys later.